Okay, welcome everyone to another QtDay workshop. Right now, we have a workshop for you presented by Luca Ottaviano called Create User Interfaces with Qt on Raspberry Pi. So let's go ahead and bring Luca up and we can go ahead and get started. Luca, you are not enabled. You might have to change that. All right, while we wait. Oh, there he is. Okay, great. Now we can enable.
Yeah.
Hey, there's Luca.
Hey, everybody.
Wonderful. So Luca here is a software developer with over 10 years of experience in embedded systems and Qt development, and he is specialized in training and mentoring new developers. So what about this workshop? What do you need to know to develop user interfaces on embedded devices? In this quick workshop, he'll help us take a tour of QtQuick and the basic concepts of cross-compilation. You'll first develop a simple desktop application, and then he will show you how to compile the application on the target device. So before we get started with that, I just want to remind everyone that if you have questions to ask during the workshop, we love questions. Please direct them to the Q&A chat. That's the one with the little question mark button. That's not the help button, but please ask your questions there just to keep things organized. All right, we'll have a good workshop, and we'll see Luca in just a moment after the intro video.
Hello, everybody. I'm Luca Ottaviano, and you're here. I will show you today how to build QtQuick applications on Raspberry Pi. Just a warning, just before we start. This is a very basic workshop, so if you ever did something with QtQuick, or if you followed the Qt Lab yesterday, or in any way you have some experience with Qt, maybe you will get a bit bored. So keep that in mind. And also, unfortunately, I couldn't send you a Raspberry Pi each, so the Raspberry Pi part will be kind of simulated on my hardware here. Yeah, okay. So I will tell you how to do it. But if you want to, I will give you instructions on how to replicate the setup. I can share a link as well where I have the root file system for this. Sorry. Yeah. So for I have the root file system that I've used for to prepare this workshop. You have the instructions there. I will share you a link in a moment. Here we go. Link. Okay. So, and here's the link. Okay, and you can try to replicate the setup. We have. I hope you all have you have downloaded the repository, which is here. Okay, and we are going to use it. You have the slides over there, so you can you can follow along on your PC if you want. And we will use this template. We will use this code to create our application. I will explain you later on how the repository is organized. Okay. So let's start. Okay, so today's goal is to create a car dashboard. We are going to use QtQuick to build the various components that that make up this interface. Okay, so we'll start by creating the UI, starting from graphical assets. We have they are provided on the repository. We will see how to integrate with C++ code. I will give you a cross compilation overview, and so what cross compilation is and how you usually use it. And we will compile the application on the Raspberry target. And finally, if time allows, I will show you the usage of a special plugin which is called WebGL Streaming that allows you to run the application on the target and visualize it on a browser. Okay. And an embedded system since 2008, and I'm specialized in training and management. So, what is QtQuick? Let's start with the basics. QtQuick is a set of technologies that are used to develop fluid UI interfaces. It allows you to interact with C++, and that is used to control the system. I guess you are all used to write C or C++ code to control embedded systems, and with QtQuick you're going to write C++ code as well. Okay. QtQuick is developed by the Qt company, and it's released with 2 licenses, which are open source and commercial. Why are we going to use QtQuick? Well, because it's a batteries include framework, and it's kind of a de facto standard for embedded Linux industrial projects. And it's cross-platform, so it scales from microcontrollers to desktop applications. And it's very useful to start building your application on desktop and then deploy it on the target from time to time. And we're going to see it in a few moments. QtQuick is a set of technologies. Yes?
Oh, sorry, Luca. I believe we are not seeing your screen, if you are sharing your screen.
Oh, whoa. Oh, this is...
Okay, now we see it.
Okay.
Great.
Okay, good. Okay, so QtQuick is a set of technologies for rapid application development, and it's built of 3 main components. One is QML, that is the declarative language to write UI components, and it gives the let me say it. It gives the look and feel of the technology. So usually QML and QtQuick are used interchangeably. Then there is a runtime which executes QML code and provides the JavaScript engine that executes the code. Finally, we have C++, which provides the backend, the UI backend, and it integrates with the machine. Okay. So, as I said, QML describes the components that are part of the UI. And you can also handle the user input using the mouse, the touchscreen, or the keyboard. You can also use multiple finger gestures and so on. QML executes in a sandbox, which means it doesn't have access to all the things that C++ have access to. So for things to be visible to QML, they have to be exported. And we'll see that in a moment. On the other hand, C++ communicates with QML through some blessed object or exported objects. It interacts and controls the machine and runs an unrestricted code. So you can do whatever you want, as in a normal C++ application. If you run on an embedded Linux, you will have the limitations of the user which is executing the code, but that's regular Linux system. Okay, let's see the basic concepts. Here is a snippet of QML code that draws the image on the left. So we have a rectangle, and we have two rectangles, one inside another. The outer one is black, and the inner one is red. Okay, a QML file is divided into two parts. One is the import block, and the other is the object creation. The import block is on the top, must be on the top of the file, and must be present before any object creation that you may want to, that you are going to write in the file. And here we have just a single import. You may have multiple imports, for example, if you are going to use QtQuick controls or Qt virtual keyboard and so on. Next, we have the object creation part, where you are going to actually write what you want to draw on screen. The object creation is exactly what the word means. It exactly creates the objects. So here we have two rectangles, and these are objects of type rectangle. There are many more types of objects, and these objects are placed on a scene, which is then drawn on screen. Bear in mind that here you can see in the file that the objects they form a tree of the structure of the file looks like a tree. This is because implicitly in QML there is a tree hierarchy between all the objects. So the first rectangle, the outer rectangle, is the root object, and all the other objects that you are going to create in this file are children of this root object. And the instantiation position defines the position in the hierarchy. So yeah, so if you put another element inside the red rectangle, that element would be a child of the red rectangle, and so on. Also beware that these two red circled objects are not drawing commands. They are object instantiations. In QML, there are almost no direct drawing commands. Okay, everything is an object instantiation. The QML file then is parsed and interpreted to create a scene, and the scene is then drawn when needed. Any object may have at most one parent, and the object without a parent is the root object. We have a limitation in QML, and this is by design, that for each QML file, any QML file may have only one must have only one root object. Okay. Then we have the ID. Each object may have many properties. One is the ID, which is a unique identifier of the QML object inside this file. It may start with a lowercase letter or an underscore, and it must be unique inside this file. What is it used to do? It's needed to refer to this object inside the QML file. So, for example, here we see that the inner rectangle uses the reference to the parent rectangle to take the width and the height. Okay. Okay. Then each object exposes some properties. And properties are have a type, and they control the aspect and behavior of the object. So everything in QML, almost everything in QML is done with properties. The most important part is that you can bind properties together. This is very important. And this is the most powerful thing you can do in QML. A binding describes a relationship between two properties, and whenever you establish when you have established a binding, every time any property mentioned on the right side of the binding changes, the whole expression is evaluated again and is assigned again to the left side of the binding. Okay, and this is done automatically. There's no need to do anything, and this is really important because it really allows you to declare what you want to achieve and not how you want to achieve it. Okay. So, property, we said that properties may have types. Types may be provided by JavaScript, and which are, these types are int, bool, real, or double. Then there are string, URL, list, var. Var basically is anything, is untyped variable, and in fact, you are not. It's not advisable to use it extensively. Then we have properties, but then we have types provided by QtQuick, which are color, font, date, time, point, etc., etc. We have also types for visual types. The basic one are item, which is basically it's an item that has an area. It has no visual aspect, and it is the basis for all things that you draw on screen. Then we have rectangle, text, and image. These are the ones that we are going to use the most in this workshop. Rectangle basically draws a rectangle. Image loads an image from the file system and draws it on screen. And text, well, it draws text. We have also row and column, for example. They don't have visual aspect, but they are used to position elements. And we have also input types. For example, a mouse area. A mouse area is an area where you can click, tap, and so on. Okay, let's talk about how to position element on screen. So, you can create complex design by assembling together simpler objects. And this is this is the whole point of QML. You are going to assemble a lot together, the various pieces that are already present. There are three main methods to set the position of an object. One is using containers, such as row, column, then we have grid, we have various layout types, and so on. Or with anchors. And finally, there's even absolute positioning. We are not going to talk explicitly about absolute positioning because I think everybody understands that. So you set the X and Y of each object, and that's it. But I mention it because sometimes in some projects it may be useful to just stick with absolute positioning, especially if you have complex animations that move a lot of objects around the screen. And if for example, if you have a complex structure to position your elements, sometimes it's doing such animations becomes difficult. So you also have absolute positioning at your disposal. Okay, so here's an example of containers. We have here we're on the left side. You see a component that is composed of three images and a row. So we have the outer component is a row which positions the element horizontally, and we have three images. You can see here how to use the image component to load an image and draw it on screen. Okay. And here you can see that basically row is just doing is already doing the positioning. We haven't specified for any of D, N, and P images where they are on screen or their relative positioning, but just by the fact that they are children of the row, these elements are positioned correctly. Okay, 1.2 remark is that the row has no authority on the sides of the children. It is just a positioner, so it's it doesn't decide the inner. It doesn't decide the width of each element, and so each element has its own width, and the row just places them horizontally. Yeah, as you can see, containers are logic elements and they don't have any visual aspect. Next up, anchors. Anchors are an alternative positioning method, and they control, in contrast with the row and column, they control the element's position in sides, and they rely heavily on property bindings. So, for example, here we have a simple, on the left, we have a simple binding. And so imagine you have two items, which are A and B. In this case, they are two rectangles, and you can position the element B, the rectangle B. You can position it on the right of A by setting its left anchor. And while we have another example on the right, where we have a small rectangle inside a larger rectangle, and you can say that you can if you want to center the inner rectangle inside the outer rectangle, you can just say anchors centering big, okay? Where big is, of course, the ID of the outer rectangle. So let's see anchors in deep. Each element defines these anchors. So you have the left, the horizontal center, and the right anchors, and the top vertical center and bottom anchors. So in the previous examples, for example, here if you see on the left, we have A, and okay, we have set the anchor, the left anchor of B to be we have bound it to the right anchor of A, okay? But basically, since this is a binding, if in any case A moves around, B will follow. Okay. Okay. You can attach pretty much. Okay. Anchors are typed. You can only attach a vertical anchor to any vertical anchor. You can, of course, you cannot attach a vertical anchor to an horizontal anchor. For example, you cannot attach left to a top, because it doesn't make any sense. Okay, because top is horizontal and left is vertical. But you can attach, for example, a left anchor to an horizontal center. So in this case, you will have the element that is basically always the left edge of the element is always attached to the center of the other element. And the same goes for horizontal anchors. You can attach horizontal anchors to horizontal anchors. For example, top to bottom, top to top, if you want to have the elements at the same x, sorry, at the same y. Okay. In this context, you have also fill and centering. These are two different anchors and are basically shortcuts. Anchors fill means attach all the anchors, all the border, let's say, all the border anchors to the same anchors of the target. So, for example, this is usually used if you want to make a button. For example, you have a rectangle and you put a mouse area inside, and you say anchors fill, and that mouse area automatically expands to fill the whole rectangle. Centering is another shortcut, and basically sets at the same time the horizontal center and the vertical center, which is what we saw in the previous slides here on the right. Okay. Okay. Here is an example. Okay. So this is the component. This is the component we are going to build, and the code, the component on the left is built with a code on the right. So okay. I'm just repeating what I already said. So you can, for example, here we have an outer item, which I'm going to call but, and the image for the battery is anchored to the top of the outer element, and the same, the horizontal position. The horizontal position is centered with the horizontal position of the outer element. Okay, so this also shows that with anchors, usually you need at least 2 bindings to correctly place an element, because as in it is the same as absolute positioning, where usually you need to set the x and the y of an element. Likewise, when you're using anchors, you need to set the vertical position and the horizontal position of the element. So usually if you want to have something that is centered, you use horizontal center, and if you want to stack the elements one on top of the other, you do what we do here in the code. So you set the top element on the top and the bottom element on the bottom. Okay, you can also apply anchors come with margins, and margins are simply integers that you can that they are pixel values, and you can apply them only if the respective anchor is active, is set. So in this case, it makes sense to have a top margin. It makes sense to have a top margin here, because I've set the anchor stop. It wouldn't make sense, for example, to set a bottom margin, because in this case I have no anchor's bottom set on this text, and so the margin doesn't apply. Okay, let's talk a bit about components. Components are used to assemble together simpler objects, and they are the main method of code reuse in QML. Let's see how we can create a reusable component for the battery. This is imagine that the code on the right is a file that you already have. Is something that you're using. How can you make it reusable? Well, first of all, for example, you see that we have a text here. This text is fixed. It's placed there, and we have no way of changing it. So the first thing we do is we add a property on the root element of this component, and we use this value on the text. Okay, and we are going to we just concatenate the value of the battery now with a %. Okay, so that this text shows something. Okay, the property that we just added on the root element becomes the component's interface. So it's what the outer code, the client code, will interact with this item. Okay. Then, done this, we can save this file in with an uppercase letter. And for example, we are going to call it battery QML. Then we are going to use this component inside another file, which we have on the left. Here you can see that we have on the left we have our main file. We are using battery with the open brace. This line is going to look for, let me simplify, but this line looks for a file named battery.qml with uppercase B. And if it finds it, it loads it. And okay. So, and then we have, we use the interface of the battery, which is circled in green now. And we pass on the, you can see in main QML. Can you see my cursor? I hope so. I can see it on the display. So here we set the battery. We are using a binding. You're using a binding to pass something to the component here on the right. Okay. So what is this control unit of battery? Well, we are going to see it in the exercises, but basically it's a C++ class that exposes a value. And this is how we can link values that come from C++, and we set them inside our components. Okay. Okay. So yes, that was the explanation. We're going to start building this application. Okay. Let's build the first component together. I'm going to take it slow now. I assume that you already have cloned the repository. I hope so. So, first a bit of a word on the repository. So there is a tag for each step we are going to do. So don't worry if you fall behind. There are checkpoints for everything. My suggestion is this one. You can start with step 0, which is what I'm going to do. And there, in step 0, you can create your branch, so that you're not on the void. You know that if you git check out a tag, it's something completely useless. You're going to lose your, if you do any commits there, you're going to lose your work unless you create a branch. So my suggestion now is to open the repository, git checkout, and issue these commands: git checkout step 0, and then git checkout -b and name a branch. Okay. Okay. So let's analyze a bit how what we need to do here. We need to there is already a skeleton application that draws the background of this dashboard. We need to create 4 text elements for each of these texts that we have below. We have kilometers, we have a temperature, we have a date, and we have the time. Okay. So the steps: create a new file which is called statusbar.qml. Okay. You can do that if you are in. If you have Qt Creator open, you can do that with Ctrl-N or file. Let me double check immediately. You can do file, new file or project, and then you can create a QtQuick. You can create a QML file which is called. Let me share. Let me share this screen. Okay. Whatever. Okay. So let me just know if you have problems in creating a new QML file. Okay. Then create inside that file, create these 4 text elements and position them with anchors. Okay. So yeah. Okay. For now, don't worry about the size of the root element, because usually just give it a size that seems reasonable for you now. Let's say I have no idea now, but let's say it's something like 400 pixel width and 20, 30 height, something so that you have something to see. Okay, then use status bar inside the main dashboard. Okay, and here you're going to set the width and the height of the status bar, actually. And so that's why I said we don't need to care about the size of the status bar when we are writing the QML file for status bar, because usually the sizes are set from the outside. Okay. Okay. So yeah, you have your time, and yes, let me just know if you have any difficulty now. I assume you can all open the project, compile it, and run the application as is. And I'm going to do the same while you write your code. I will leave you something like let's see, up until half past 3. So 20 minutes, 50 minutes, and then we have a break. Okay. I'm going to implement the same thing. So okay. So I'm creating a new QML file, which is called status bar weight. Okay. So we have 4 text elements. And So we have 4 text elements, and we have the length. So it's kilometers, which is text. -23 degrees. By the way, for now, you can just use fixed text. I suggest you use fixed text, for example, also for date and time, because there are you can use JavaScript objects, for example, to update the text to get the current date time. But you need to do some conversions because it's not just you need to format the date anyway. So I just suggest you that at start you just use fixed text. I need to set the color of the text. Okay. Okay. And now I need to decide where to put. I need to decide the positioning of these elements. I could use a row, so a positioner. So for example, like this. But in this case, I think it's not really useful because we have a big space in the middle, and for this case, the row usually just evenly spreads the text. Not evenly, but we would need an empty item to fill in the space in between. There is no way to specify to the row that we have a big space in the middle. So in this case, I think the row doesn't fit, and I'm going to use anchors. You could use also a row, of course, but in that case, you could use also absolute position. So. Okay. I have coded a status bar, and I don't know if it's okay or not, and I'm going to use it inside main dashboard. So here we have a to do. I'm going to use a status bar here. Okay. So since I'm in my main file, here I need to set the size of the status bar. So the height, I have no idea how is it. So something like 30. Of course, I should have these numbers from the designer, but in this case I don't have one and I don't have references, so I'm just putting some numbers out of my mind. Okay, any questions till now? No. Okay. Okay. The idea here is that since I've okay. So whenever you use a component like this, like our status bar we have built now, you always need to specify the size of the component and the positioning on the screen. In this case, most of the time, components will have their own implicit size. So they already have a size. For example, whenever you load an image, that image has already an implicit size, which is the natural size of the PNG, for example, that you're loading. In that case, you just need to position the element. But in the case of the status bar, I need to specify both the size, so the width and the height, and the positioning. Okay, I've used anchors, both left and right, which already tell me the sides, the horizontal sides of the element, and the positioning as well. And then I'm using the height here to specify the height of the component, and but what I'm missing without this line, for example, what I'm missing is that I need to position the element. So, for example, if I just run this code, you can see nothing. But in fact, I think you cannot see. I've shared only one window. Okay, so let me share all the screen. This one. Okay, let's hope we don't do something. Oh, here we go, Inception. But anyway. Okay. So if I run this application, okay, I cannot see anything. Good. What's up? Okay. Okay. This is embarrassing. Okay. I cannot see anything. Good. Let me see if I have any errors. No. Okay. Okay. No, I think the problem actually here is. I think the problem here is that in my code, I have something like DPI scaling enabled, and I don't have some. Yeah, there we go. Yeah, it's because I'm on Linux, and then I have two very different monitors attached, and then I was seeing everything black. Okay, so basically, okay, we can see here we have up here just a bit of text. The other probably is lost somewhere here in the white. So see, if I was saying that if I don't put the anchors button, then the element has the default. Let me use anchors button, and probably okay, it's a bit better. Okay, so I just need to put some margins here, and then maybe increase the font size, something like this. Okay, and maybe increase also the margin. And I think this is something like 50. Okay, looks better. Okay. Do you want to stop the recording? No. Okay. How's it going? Everything up? Everybody's up to speed? So, we made our first QML component. I hope you enjoyed it. We have, for example, I can make it tick, but I don't remember how to format the date in JavaScript. Okay. So now I'm just trying to use the current date time to format, to put in there in the status bar. So it's something like, and I'm using a Qt function to do that. Okay, it's working.
Are you ready for a break then, Luca?
Yes. I think we can have a break now. And yeah, if you have any question, just prepare them. So you can write them.
Perfect. Yeah, we'll be waiting for them. So it's 35 after. So we'll see everyone here at 40 after. Get a cup of coffee or whatever you need.
Okay.
All right. See you soon.
See you later.
Here we go. All right, everyone. Welcome back from the break. Hope you had a nice little pause there. We're ready to start with the last half of the workshop. So, Luca, when you are ready, let's bring you live.
Yes.
There you are. All right. Have a good workshop.
Thanks. Okay. So, I hope everybody's on board. Let me share again. Okay. So we built our first component. Okay. We have created it. We have created it with 4 text elements. As I said, it's not easy to use a row in this case to position the elements. So you have created your first component, which is the status bar. You have positioned the element correctly, and you have used this component inside the main dashboard. Okay, good. That's nice. In this case, as I said, it's probably not easy to use a row, because the row doesn't have, it has a spacing property that you can use to space each element about the same size. And so it's difficult in this case to have a big space, an uneven spacing inside the component. You can fake it, for example, with an empty element of the correct size, but as we saw, it's easier just to use anchors. Okay, let's build the next component, which is the base for the odometer. Okay, so we have these images, and yes, we are going to use those to build this part. As you can see, much of a QtQuick UI is built on images. So it's a QML UI. You're going to have lots of images to build together. And in this case, we have 4 images. Okay, so sorry, checkpoint. In case you didn't make in time, you can use these commands to come up to speed. So we are currently in step 1. So in step 1, we have created the status bar, and we are going to create the odometer. So if you are on your branch for step 0, you just can git commit everything, in just in case you want to save your work. Then you can git checkout step 1, and then git checkout -b my branch step 1. Okay, so you're going this way you're going to create another branch for step 1, and branches are cheap in Git, so just create it. Okay, so odometer. Okay, the odometer is composed of multiple images. Sorry, they are in Italian, but anyway, just open up the directory and have a look at the images. These are, if you have the repository, the images are in the images directory. Open the images directory and have a look at the images. So, yeah. If you see, these images should be stacked together. So should be stacked one on top of the other. okay? And by looking at the images, you should figure out which one goes at the bottom of the stack, which one at the top. The images are the one that I listed in the first point here. Okay. So there is QtGiri top, and there is QtGiri back, and there is what is Gera più numeri and centrale. Okay. These components, have a look at these images and create a stack of elements that which the bottom of the stack is the outermost image, okay, and then you build the stack by creating an element as children of the first, okay. Okay, and in this case, open main dashboard. We're not creating a new component for this for this step. Just open main dashboard, and above status bar, put this stack of images. Okay. Yeah. Go. Of course, this is the slide for the next step, but what we want to achieve is okay. Yeah. I will give you some time to create it. Of course, the component that you're going to use in this case is the image component from QtQuick. And you can set, you must set the source property of each image to the file name that we have. So it will be, I think the bottom one. I think the bottom one will be QtGiri bottom, QtGiri back, and you should not set. In this case, you should not set any dimension on the image, since the images already have an implicit size, and so they should be they already should be about the correct size. They should be already correct. Just contact me if you have any problem. Okay, if you, like me, just build the images one above the other, like in this case, as you can see here, should probably be in this situation where the images are there, but they're not really aligned. So this is because I forgot to position the elements. So let's go on the outer element and position it horizontally. Okay, much better. Okay, so first of all, I position the top element. So actually, the element at the bottom of the stack, and positioning the element at the bottom of the stack will position also all the children. In this case, the assets are correct in the sense that they are meant to be stacked on top of each other, and they have the same center. So if you just use center in this case, you can have the final odometer rather easily. I will leave you for 4 minutes more. Are you still? Okay, Claire is ready. Okay. So we are almost there, don't worry. And okay. Next up, we want to insert the battery and the speed. Okay, so just in case you didn't make in time, we are going to start with step 2 now. So again, if you want to commit your work and review it later, you can commit everything in your new branch and check out step 2 and check out again, create again a new branch. Okay. Okay, so there is a battery image in the repo, but let's start with text, which usually is a great choice because you can immediately see what's there. And if for example you made some mistakes on the QML side, on the C++ side. In this case, we are going to create a new component called cruise. And so you must create a new file called cruise.qml. And we're going to add a battery property on the root item. Next, we are going to add this cruise element in main dashboard on top of the latest image of the previous step. Okay, so we have made these hierarchies of images. Most element, we're going to put this cruise. Okay. We can use control unit dot battery to read the battery values from C++, and we are going to set the binding inside main dashboard to our cruise element. Okay, so yes, this value is read from C++. Okay. Control unit, basically, control unit is an exported object, is a custom C++ object that we already created, that is pre-made for this workshop. You can find it, is it called in, well, control unit.cpp, in case you want to have a look at how it's done. It's really simple. Okay, and it has a property which is called battery, and this changes values. This changes values during the with the passing of time. Okay. So, well, yes, you have. I will leave you another 15 minutes to do this. Okay. So take the step 2, and these are the steps we want to have. Okay. Sorry, this is for the battery, and then we have a similar thing for speed. When you've done with battery, you can add the speed property as well on the root element of cruise. We can add a text element to render the speed, and use control unit.speed to read the current speed from C++. Okay. That's all for now. Okay, so I'm going to create a new QML file. Cruise. Oh, sorry. Sorry, it's fine. Okay. So currently I'm just I'm going to use directly a column because I know that there will be I already know that there will be speed and battery elements, so I'm using a column to stack one above the other. Okay. Okay, so let's put, don't forget the color. Oh. Okay. Okay, let's speed up a bit. Oh. Okay. Let's see what happens. Okay. If you're here like me, you can see that the speed changes too much, and it has too much precision for what we care. And this is basically because all JavaScript numbers are reals. So we have to format the number using a fixed point notation. So for example, something like this. So we only need, we don't need any precision after the dot. So I'm setting the speed to fixed 0. So this basically rounds the number to 0 digits after the dot, and the same I'm going to use for the battery. Yes. Okay. This is a bit better. Okay. And on my code now, I have that the speed and the battery are aligned on the left. So probably in this case, I would like to center everything, and I'm going to use the anchors horizontal center to set the centering. Anchors horizontal center, horizontal center. Okay, much better. Then I'm going to set some spacing here. And maybe set the font a bit bigger. Okay. Okay. I hope you reached the more or less this status. I just want to show you something on the Raspberry. So yes, if you have any questions, we can discuss it. Otherwise, I'm going to go ahead. So okay. Let's see, speed. Okay, let's spend a couple of words on cross compilation and what happens now. Now we have a C++ application. We have compiled it on our desktop. We have it running. So far, so good. Okay, now we have to put the application on the target. The target usually, what is the target? Target usually is the exactly the target board here. Okay, now it's switched off, but anyway. So what is cross compilation? When doing cross compilation, you use your PC, which is called the host, to generate code for the target, for the embedded board, which is called the target. Okay. Usually the compiler for the target generates code for another architecture altogether. We have currently your PC is running an x86. It's running x86 code. Embedded boards like Raspberry run ARM code. So we need a compiler that is able to composed of x86 instructions, but that generates code for another architecture, and this is called a cross compiler because it compiles cross architectures. Usually we use cross compilation because the host machine is much more powerful than the target, and we don't want to ship a compiler on the target. Let's say you're building a UI for industrial oven. You don't want to ship a compiler inside the oven, and you don't want also to ship development tools on the oven. Okay, and this is why we use cross compiling. In this workshop, we will not use proper cross compilation because usually the Raspberry target requires a Linux host. So whenever you compile for an embedded board, usually the compiler runs on Linux. To cross-compile the code for the Raspberry. We have very little C++ code, so we can compile directly on the target, on the Raspberry that we have. So basically, we will copy. I'm going to copy the project on the target, and then I can compile it. So these are the commands. I'm just going to copy the whole directory. And then inside the Raspberry, and then doing the classic QMake and make. Yes. So for those of you who don't know Qt, whenever you have a Qt project, you can use QMake or CMake to generate a make file, and then you run make, which compiles the application. Okay, so I'm going to just share my screen again. Yes. So in this case, it's a bit dark. I hope you can see. Let me. Oh, okay. So. I'm just going to use rsync to copy the files on my Raspberry. And the user in this case, I'm copying those in home P, which is the user I'm using on the Raspberry. This is the most secret password, which is Raspberry by default. And here I have here. On the other shell, here I'm on the Raspberry, and I enter the workshop directory. To compile, I run qmake, which generates the make file. So okay, let me clean up everything. Okay, and this is not going to work. Whatever. Sorry, but basically this is not working because I've not set the correct date on this board. Whatever. I don't remember the format now. Okay. So it's month day. I cannot understand this. This. Sorry, but anyway. Okay. Okay, so let's suppose I've already compiled this application. Okay, and to execute the application on the target, I need to just run the application. Okay, and in this case, I need to do export display because basically otherwise Qt cannot understand which display is attached. So if I go back to the shell, the first thing I need to do is turn on the backlight. Otherwise, we will not see anything. Is it working? No. Okay, so no, it's not working. Let's try the down thing to turn it off and turn it on again while we wait. Yes. So so while we wait, I will spend some words on WebGL streaming. What it is? Basically, it's a platform plugin to expose a QtQuick UI to the browser. So the UI is not rendered on the target, but it's rendered on the browser. So it's for those of you who know about WebSockets, basically the application starts. It doesn't start locally, but it opens a WebSocket server port, and then the browser can connect to the application, and the application sends drawing commands directly to the browser. It has some limitation though. For example, access is single user only, and yeah, because basically it's not a real web application, but it's just a desktop application that is running on another display. So in case of multiple connections to the same application, only the first user can interact and the other wait. So okay, so here we have the display. So so export display. And then let's hope I didn't clear everything. Yes. And it's working. Okay. Well, now of course, I developed this application on the desktop, and the resolution is much bigger than this display, but it's working. Okay. So the other thing to try is to use platform WebGL. So I've stopped the application, so here we don't have anything. If I start the dashboard with -platform WebGL, you can see that it doesn't draw anything here, but I can connect with my browser. Where is my browser? Here is my browser. And which one was the? Okay, Raspberry Pi local. Okay. Yes. Okay, so you can see here this. What you're seeing here is the same application that is running on the Raspberry, but the drawing commands are not sent to the display of the Raspberry, but they're sent to the WebGL streaming plugin. Currently, here you can see that it's not drawing correctly. The blue line is not drawn correctly, but I think it's just a problem with the version of Qt that I'm using here. It's rather ancient. It's 5.11 or so. So yes, I didn't have time to update the toolchain that was on the Raspberry for with 5.15. Okay, so that's it. Yes. So that's it. Okay. This is all. Okay. So yes. I'm looking right now at the comments. You suggested to touch all the source files. Yes. Why not? We can try, but basically touch. Okay, so the idea is here we do make and make. Okay, so make clean. We can try to. Okay, there. So this what I'm showing here is that we are compiling our application on the target. So as you can see, the Raspberry is rather powerful to compile this application easily. This is not usually the case for big applications, so a cross compiler is needed. But yes, here are the basics. Oh yeah, sorry. Desktop share. Yes. So yes, here is the compilation. So I can clean. Yep. And then in this case I don't have anything. If I run QMake, you can see that here QMake creates some make file. And then now I can run make. Okay, or the issue of the build system, because here you can see that it has created all the build files in this directory, but this is another topic. Okay.
All right.
I hope you enjoyed the workshop, and I left you the. I think you all have the links to the material. Okay, we have some questions.
Yes, Simone is asking, what happens if I need to compile code with C++ working only on RPI?
Yes. What happens if I need to compile code with C++ working on, for example, wiring PI? Okay. You mean you have a C++ library that is that compiles only in on the Raspberry. Well, in that case. Okay, so in that case, either you compile directly on the Raspberry. So in that case, well, you don't have any problem because it's the target system. If you're running a cross compiler on your host, in that case you need to have the root file system, and you need to have the headers for the library installed on a path that the compiler knows. Otherwise, the compiler will not find the the library and cannot link to it. Usually for if you're doing a let me say if you're doing a project for a professional in a professional setting, usually you're going to use a build root or Yocto to have the system to have the root file system for your board. So yeah, the library should be either is already on the root file system, or and that is so that problem is already solved because the compiler already finds the library. Or if you have a root file system for the Raspberry and system, then in that case well, you just compile it, and then you have to adjust the build the project file. Here you remember we use QMake. It's QMake will generate the correct information to build your application, and you need to modify the .pro file to include with the include paths for your external library and so on.
Awesome. Thank you for that information. It seems a lot of people have appreciated all of that information. Thank you.
Yeah, I think we have another question, which was, what do we need on Raspberry to compile? Buster OS is enough. Hey, so the application I've shown you should be compilable on anything that has Qt 5.11 or above. But the WebGL streaming plugin is not available by default on that in that distribution. I don't remember the name. Sorry, I don't remember the names about of Raspberry root file systems. I think I've used Buster, but I don't remember. The WebGL streaming is not included in 5.11 because I think it graduated to a supported module in 5.13 or so. So for this workshop, I compiled the plugin from the sources. So if you want to use WebGL streaming with Qt 5.11, you need to compile the plugin externally.
All right. Yeah, that it seemed was the only other question I was about to get to. Great. Yeah. And Simona said, thank you. So if anyone has any other questions, Luca, where can they find you?
Yeah, you can find me on either on Twitter or you can send me an email at luca.ottaviano@develer.com. And yeah, that's it.
Fantastic. Well, thank you for a wonderful workshop.
Thanks
too. Awesome. All right. Well, Luca, always a pleasure to see you, and hopefully we'll see you around next time too.
Okay. Thanks. Thank you everybody for attending, and see you next time.
Yeah. See you next time. Thanks.
Bye-bye.
Right, bye-bye. Okay, you guys, so before you leave, I just wanted to let you know for what we have for QtDay tomorrow. We're starting with a recruiting session by Develer at 12:50 p.m. Italian time, followed by how to scale QML-based projects in an architecture vision at 1:20, followed by better UI HMI development workflows with Qt and QML, and then what's new in 3D for Qt, 5.14, 5.15, and beyond, cross-compiling Qt applications with CMake. And then finally, we have our keynote tomorrow at 6 p.m. Italian time, Qt Containers and Algorithms, presented by Thiago Maschiera. So hope to see you in some of those tomorrow. Have a great evening, and yeah, we'll see you later. Thanks. Bye-bye.